Hello, everyone. Today is day 2 of our Unit 2. And today we are talking about more reasoning and proofs. And at times in geometry, there are statements that are not definitions, but we know they're true. And there are two types of statements that are this. There's the idea of postulates or axioms. These statements whose truth is assumed without any proof. These are things that have happened for years and years and years, hundreds of years, but we know they are always true. And then there's a theorem. This is a statement that is proved by deductive reasoning. So these are things that we already know have been proven to be true, so we can use them in our proofs. Sometimes we are going to prove theorems. So equality postulates. So this is the reflexive property. It's a quantity is equal to itself. So we can say that AB is equal to AB, or the measure of angle B is equal to the measure of angle B. This seems kind of redundant, but when we start to do proofs, it's going to be important to identify that a segment or an angle is congruent to itself because we're going to use it in two different shapes. The transitive property. This is something that kind of makes sense, but it's going to be important for us to use. It says if A equals B and B equals C, then we can kind of take out the B's and just say that A equals C. So how we would use this in a proof is, in this example here, we say that AB is congruent to CD and CD is congruent to EF. So the fact that AB and EF are both congruent to CD, that means that AB is congruent to EF. So in our proof, we would write that as our statement, and our reason would be transitive. If you'd like, you can say the transitive property, but you can also just say transitive. Our third property is very, very similar. It's the substitution postulate. So a quantity may be substituted for its equivalent in expression. You use the substitution postulate all the time when you're doing algebra. When you solve one equation and find x equals 2, and then you substitute that into another equation. We can use that idea when we're talking about the lengths of segments or the measure of angles as well. So if we look at this example, we know that AB equals 2 times AD, and then we know that AD equals DB. So what we can do is we can substitute DB in for AD in that equation. So that would mean that AB is equal to 2 times DB. And that is substitution. So now let's see how we can use some of this together. So we know that the measure of A plus the measure of B equals 90. And we also know that the measure of angle A is equal to the measure of angle C. So I can use the idea of substitution to say that the measure of angle C plus the measure of angle B equals 90. And that would allow me to say that C and B are complementary. Addition postulate. Addition postulate says if equal quantities are added together, the equal quantities, the sum are equal. You used this when you were solving equations using substitute or elimination last year. So in order to add things together, you have to have two equations. You have to have two statements, such as A equals B and C equals D. And we can add these two together and say A plus C is equal to B plus D. You could also add them together and say that B plus C is equal to A plus D, because we could use the symmetric property, which you're never going to have to write in a proof, to flip A equals B to B equals A, because if two quantities are equal, they're equal. So here are some examples that I would like you to pause the video and then come back and check your answer. If you have any questions on these examples, please ask me during class tomorrow. If my explanations in the video did not completely answer. There are 3 examples, so pause, come back and check your answers. Okay, so I might go over example 1 with you here a little bit. So the first thing Okay, So sorry about that, the bell rang, but let's finish this up. So I use the addition postulate to add the equations given in step 1 together. And then I use something that we learned in chapter 1, which is segment addition, that if we look at this drawing, that AB plus BC, that equals the entire thing of AC, and DE plus EF equals the entire thing of DF. So that allowed me to prove that AC is equal to DF. So now I'm going to go through this example. So we are given that the measure of AD, so the first thing I always write down is my givens. We're given that the measure of ADF is equal to the measure of CBE, and that the measure of angle EDC is equal to the measure of angle ABF. So that in our reasons is given. And then step 2, if we look at our drawing, we're trying to prove that ADC is equal to ABC. So ABC is really ADF plus FBC, or CBE, and ADC is equal to ADF plus EDC. So I'm going to use my segment or my angle addition. So I'm going to first use addition, ADF plus the measure of angle EDC equals the measure of angle CBE plus the measure of angle ABF, and that's addition. And then step 3 is that the measure of angle ADC is equal to the measure of angle ABC. And that was angle addition. And then another bell, sorry about that. We will go over example 3 in class tomorrow. Have a good night.